quarter to 11, right? Okay, in the meantime, I share my screen. Do you have any questions from what we discussed the last lecture? Okay, so I guess it's a no, and everything is clear. So I'm happy to know it. We have 4 more hours to go and to work together. Just to give you an idea of what we will go through. Let me go back to one of the slides that I've presented last time, so that it will be easier for me to express this. If you remember, when we have discussed about the importance of standard and the standardization procedures, we went also through this slide that represents what is the evolution of the environmental management standards, of the voluntary tools for environmental management. As you can see from this slide, there is a clear evolution. We can see there is a clear evolution in what standards for environmental management are meant for. When in the 90s, early 90s, the first to be implemented were related to the environmental management systems. Just wait a second. Let me see if there is someone else to admit. I don't think so. Anyway, afterwards, it was the time of environmental management of product standards, which specifically include the life cycle assessment approaches and tools. This is what we will discuss today, and probably also part of the next lecture. Afterwards, it was a turn of the communication of environmental assessment results. This is what we can see as the 3 main elements of the environmental management tools that a company can decide to implement in order to define a strategy with reference to environment. What we see nowadays is that all of these 3 aspects, specifically 1 and 2, are results in a combination of the new standards cannot be classified anymore specifically in number 1 and number 2. That is why there is a common ground that is a basic concept of all the voluntary management tools that refer to the life cycle approach. In fact, nowadays, what we see is that there is no clear distinction. These are the latest standard published for 2001 now, follows within this group. Well, we cannot clearly identify differences or between a process approach and the product approach, because at the ground of these are the life cycle principles. Also, communication, no matter if it's related to product organization, is based on the life cycle approach. We have tried to stress this concept a lot in the previous lecture when we went through the main requirements and aspects related to environmental management system. What we will do today is to go deeper inside the topic of life cycle approaches and tools. How are we going to do it? We are going to do it through the presentation of the main requirements, and I will try to be a lot, I would say, operative. I mean, I will try to give you a lot of advice and examples on how to implement these requirements in real life. We are going to talk about life cycle assessment. I'm pretty sure that you remember last time that we have stressed also the importance of avoiding burden shift. And SCA is the tool that allows to prevent these issues. So shift the problem somewhere else. It can be a life cycle stage. It can be an environmental category. It can be, in some cases, also the from one system to another. Think about a company that has many different sites. The way I manage the production with this company can result in environmental burden sheet. So let me close the heating system because it's too hot now here. So let's go ahead. Let's move ahead. Let's start discussing about life cycle assessment. And let's do it by introducing the definition of life cycle assessment. Of course, easily understand that there is a life cycle approach that we have already discussed, and life cycle assessment is a tool to implement the life cycle approach. It's one of the tools, but when we look at products, life cycle assessment is probably the most used and successful tools that nowadays companies can decide to adopt in their environmental strategy. So look at the definition. Oh, I'm sorry, it's in Italian. I forgot probably to translate it. If you don't mind, I will correct the slide and submit the English definition. Anyway, it refers to the compilation and evaluation along the life cycles, ciclo di vita means life cycle, of all the input and output and the potential impact of a product system. So let me write down a few keywords that are very important for us when we want to understand how life cycle assessment should be performed. Just wait a second, there we go. So let's look at this concept. First of all, when we are doing an SCA, we are doing a compilation, not a musical compilation, a compilation of environmental data, and evaluation. Of what? Of input and output of a product system. With product system, I will provide some example. We refer to processes. With environmental input and output, we refer to all of the interaction between the system and the environment. Let me make some example. An input is, for example, a volume of water that we withdraw from a river or from the underground. An output can be an emission to the atmosphere rather to the water that we release when the process has took place. So what we do is compilation, identify input and output, evaluation, translate this input and output in the final outcomes of the study, which is usually referred as potential environmental impact. So this is the case when a definition of a tool already gives you an idea of what you will have to do in order to implement it. Identify data, assign data as input and output, translate input and output into potential environmental impact. But let's see what the standard tells about it. So just let me move this above. And let's do it through a case study. I think it's really important to know the specific requirements. You can always read the standard. You have the basic information and the background learned from the previous lecture to go to the standards and at least understand what the standard is asking to you. But let's see how these requirements can be actually implemented. And let's see it in a case study. The case study we will go through in order to understand SCA is related to a comparison between two packaging systems. We're talking about HDPE bottle. You should have experience of this problem because when you go to buy milk, specifically in this case, long-lasting, long shelf life milk, it means that it can be stored also outside of the fridge for long periods. Of course, if you open it, it might be stored in the fridge, but that's another story. And the so-called beverage carton. This is an old question. Why old? Because most of the studies that took place in the mid-90s were probably implemented by packaging companies. Packaging is definitely a very important product to prevent food loss, food waste, and to allow people to access food in an easier way. But it's also a problem because it turns out to become a waste. So a lot of the efforts from, for example, the European Union in the 90s were to drive a change in the system from what was not recyclable to what was recyclable. Well, this was one of the questions that many companies asked themselves. Should I go for a packaging system like HDPE bottle, or should I go for the beverage carton? This is what I would like to share with you. This is a study that we performed a long time ago. It was in mid-2002, but we repeated it a few times. And I think it's a very good example to give you an idea on how to implement the life cycle assessment. So let's try to answer together to these questions. Before we get into it, I would like to know your opinion. What do you think is better? Do you think HDPE bottle or the beverage carton? Of course, we are talking from an environmental point of view. Does anybody want to share his opinion? Would you prefer to buy milk contained in HDPE bottle or beverage carton? Okay, we have Mirko that goes to HDPE. So let's say no other strong opinion. Okay, I can accept it. I can accept it because we will learn how to answer these questions adopting SCA. SCA is meant for this. It's meant to give you a better understanding of some environmental issues related to products, also organization. We will learn maybe in another time how to do that. But let's say one very important thing, SCA is objective driven. What does that mean? Sorry, I cannot shift the slide. It means that SCA depends a lot on how you define the goal of the study and the scope of your study. This will be clear in a few minutes, but as you can see, this is the very first step of our study. SCA is divided according to ISO 14040 and 44, into 4 main phases. The goal and scope definition, which once again is fundamental. We will probably spend most of the time discussing goal and scope definition because that is where you take decisions in order to perform the other phase of the study. We have the inventory analysis. At the moment, just think about this is when you do the compilation of input and output that refers a lot to data acquisition and data estimation. Then we have the impact assessment phase that comes after the inventory analysis. As I mentioned before, that refers to the evaluation. Once you have collected the data, input and output, you ask yourself, so what are the consequences of this input and output in the environment? And then we have the interpretation phase. As we will learn together, interpretation is very important because it's when you basically investigate the results of your study in order to make sure that what was your initial intention, I mean the goal and scope definition, are effectively meant and respected. That is why you see that in presentation of the life cycle phases, life cycle assessment study phases, there is these 2 arrows that goes in 2 directions, because interpretation can lead to change some of the aspects that you have basically implemented in the impact assessment, the inventory analysis, and usually in the goal and scope definition. But don't waste time. Let's try to get deeper into the goal and scope definition, and let's do it in reference to the case studies I have introduced. Take a look at this. Goal and scope definition. This goal study shall be clearly defined and shall be consistent with intended application. What does that mean? once again, SEA is goal and scope driven. So it's very important that you clarify what is the question you want to answer with SEA. There can be many questions. The one we are going through is which of the two packaging is better from an environmental point of view. But in some other cases, these studies are meant to support the identification of environmental hotspots. So where in the life cycle of the product we have hotspots and aspects that we need to investigate it more in details in order to, I don't know, for example, reduce those impacts or support the communication strategy rather than the environmental policy of the organization. That's why in the goal of the SEA, you have to determine the intended application. So how are you going to use the results? Are they meant for communication? Are they meant for performance improvement? Are they meant to support legal requirements, conformity? Well, if you're in Italy nowadays, in many public procedures, SEA becomes mandatory. Many regulation in Europe, like for example, the energy label of products, if you go buy a washing machine, you know that you have the classification A, B, C, D, and so on. Well, that is based on an SEA study that was performed a long time ago at central EU level. That is why there is an energy label with that specifically refers to the use stage. Those products, in fact, resulted to have the hotspot concentrated in the use stage. We need to determine the reasons for carrying out the study. Why am I doing this? I need to determine the intended audience. What is that? Is the study going to be used internally, like for example, research and development function, or is it going to be communicated outside of the study? This influence the quality of data that you can accept. Why am I saying this? Because if you go for public communication, public disclosure of SEA results, you need to be as much careful as you can. That of course depends on the intention, the application, the reasons, but the audience usually is very, very important. You need to guarantee that the final user, the final consumer that is not aware of what's behind an SEA study is guaranteed by the results you obtain. And then the important thing, if the results are meant for comparative assertions. What is a comparative assertion? Is a declaration of overall superiority of the environmental performances of product A versus product B. This is what we are doing with this SEA study we are discussing today. Is it better the HDP bottle or the beverage carton? Well, in this case, the answer to this question is itself a comparative assertion. But let's see together if we can basically support this comparative assertion, like HDP is better than the beverage carton, then beverage carton is better HDP, with actual potential environmental impact assessment. So let's move ahead. But first of all, don't forget that once again, SEA is goal and scope driven. So these goals are very important to be determined. Now let's look at the scope definition. There are many, many things we need to pay attention to when we go for the scope definition. Sorry, but I thought it was I'm sorry, there is something missing here in the slide. I apologize. Okay, just wait a second. There is a slide missing. I need to retrieve it from another part. I really apologize for this. Okay. Okay, just wait a second. Here I am. There we go. I share again the screen, and of course, I will upload the updated version by the end of our lecture. Okay, so here we are. We were saying once you have defined the goal and scope, a very another important thing is to determine the product system and the function of the product system. But what is a product system and what does it mean to determine the function? Well, the product system, once again, is the product we are investigating. All of the processes that are meant to deliver that product to the market. So, in general sense, it refers to all of the processes from cradle to grave that contribute to the life cycle of the product we are studying. Determining this process is very important because these lead you to ask yourself, what are the functions of the product system we are studying? Usually, this question refers to the function of the product and the definition of the so-called functional unit. So let's see what ISO 444 asks us about this. Every product that there is on the market is meant to have a function. Let's make the example of the two packaging we are studying. What is the function of packaging? Well, it actually has a few functions. Definitely, the first one is that the packaging has the function to contain a volume of something. In that case, it's a volume of liquid. But it has also the function to facilitate its transportation from one place to another. It also has the function to determine, to guarantee, the good quality of the product which is contained within the packaging. Well, it is very important once you have identified the product that you list all of these functions. Because SCA is based on the quantification of impacts with reference to a function. Let me clarify and make an example. Why can I compare the two packagings that are the objective of our case study? Because both of these has the same function. What if I want to investigate the function of repairing ourselves from rain? Today is going to be a rainy day. Well, there are many ways to answer this function. I can have an umbrella. I can have a coat. I can build a house. I can be in a car. There are many ways I can answer this need. Well, the way I decide to answer this need is going to determine what are the potential environmental impacts of that product. So that's why in the SCA, this is a very fundamental part, determine the function of the system. So one of you can also tell me, okay, Alice, thank you very much, but what if the product has multiple functions? Well, this opens the door to a long discussion, but let me try to simplify the answer to this question. Well, try to determine the most relevant function, the one that answers the need of your study, and stick with it. And therefore, try to answer try to collect all the data with reference to that specific function. In fact, when you determine a function, afterward, the ISO 14044 asks you to determine the functional unit. It is the quantified performance of the product system for use as a reference unit. Let me make an example. If the function of our two packaging is to contain a volume, the functional unit can be the unit of measure that you use to quantify the performance. What kind of unit can we use to determine the performance of a volume to be contained? What is the unit? The unit of energy is power. What is the unit of volume?
The liter.
Yes, thank you very much, Anna Maria. It can be the liter. In other cases, it could be the meter cubic. But definitely, these are examples of functional units. The reference flow is the measure of the output from processes in a given process system that express the functional unit. What does that mean? Basically, it means that if the function of my system is to contain a volume, if I measure this volume with liters, the reference flow will be the quantity of liter I am going to study. So, in the case of our beverage, in the case of our packaging that contains liquid, those two packaging are containing 1 liter of product. This is the reference flow we decide to study. Well, you understand that in some cases, the functional unit and the reference flow can be the same. Let me make some example of this process in different case studies. And let me tell you that it's a good idea. It's not written standard, but this is good practice. This is what I learned when I performed the SCA in my career. And these are the questions that usually help you to understand what is the function and how to determine the functional unit. Well, the first thing you're going to ask yourself is what? So what is the objective of our study? What is the product we are working on? We can have mozzarella. We can have other different, depending on the product, product, but what is the function of mozzarella? So you're not asking yourself what is the product only, but you ask yourself, why does this exist in the market? Probably we have mozzarella because mozzarella answers the need of people to eat. It's food, no? Food is meant to give energy. So when I will go to define the function, for example, of a mozzarella, or generally speaking, any food, I would try to answer this kind of need, this kind of function, to give energy, to give nutritional fact to a person. Well, this is already discussed, but if you go for example, this is an example of a camp. What is the function of a camp? Well, a camp is to provide services to campers, to people that go camping. Which services? Well, that depends on the specific camp. It can be, for example, the service related to, I don't know, bathrooms, no? Showers. It can, some camping may have also restaurants, no? Or if you are by the sea, usually at least here close by Padova, if you Sottomarina, it's full of camping. All of this camping also provides services to allow you to enjoy the beach, no? But this basically is what clarify what are the functions of the system. Why do these products exist? Then a second question could be how much. How much is important because it can give you the level of quality of the product, but also in some cases the quantity of the function. So we are going, in this case, with all of these three questions actually, in the definition of the functional unit and the reference flow. Well, in the case of mozzarella, how much can be probably expressed in kilocalories, no? Kilocalories is the result of the energy you get from the mozzarella or any food product. In the case of the service, like you know, the camp could be the level of services. So Maybe if I go for a camp, we have actually studied a camp a few years ago. We went to a day of presence into the camp. So in this way, you have determined the level of services. How well? Well, how well? Let's say with the example of the mozzarella, which is easier. In the case of how well, I will probably say that you have mozzarella, you have carbohydrates, you have fat, you have carbo. Carbo and fat both give energy, but give energy in a different ways. For how long? Well, this depends on the person and the people eating the product. So sometimes this guideline can have some easy answer to this question, sometimes not. In this case, for how long could be referenced for how long you can store, so the shelf life of the product. Well, all those questions drive you to the definition of the functional unit and the function of the system. This is fundamental because all of the results shall be expressed in terms of functional unit. So when we will discuss the results of this assessment, all of the results you will see refer to a functional unit. If you perform a comparative study, like we are doing, the functional unit, according to 14044, shall be the same. So whenever you compare products, you need to ensure that you are studying the two products under the same condition, exactly the same condition. So same scope, same goal, same function, same functional unit, same reference flow. Once you have determined the reference flow, it's time to determine what you are going to study in terms of processes. This is required by 14044, determine the system boundaries. So what are the processes that are going to be studied in your SCA study? How to determine the system boundaries? These are recommended by SCA standards, but this is also good practice. Determine the functional limitation. So determine which functions are excluded in a multifunction product. Determine the territorial limitation. Well, think about the mozzarella rather than the two packaging. Where are these sold? So what are the system and the boundaries in terms of geographical area of your product? Temporal limitation. When is the system you are studying and the study valid? I mean, you might imagine that processes change a long time. And so does the product, the results from the processes that's behind them. So in this way, the temporal limitation is very important. It means to determine and clarify what is the year, when, what is the period that you consider the study to be valid. I make an example. If I collect the data, only refer 1 year, let's say 2018, 2018 can be a temporal limitation. If I am performing, so I make 2 examples. If I am performing a study referred to the production of the crop, the temporal limitation, depending if the crop is a winter crop or a summer crop, can be the start from October, so 1 month, March. Can be either, in some cases, several years. So the validity goes from 2018 to 2020. Another important thing is to determine, with cutoff rules, what can be excluded because it has a limited contribution. The limited contribution, don't forget the SCA is an iterative approach, can be determined in many steps of your SCA. Usually at the beginning, it's good practice not to apply cutoff rules before you have to perform the impact assessment, then you can apply the cutoff rules. But let's go and additional information to you in order to make you better understand what we mean by system boundaries. This is an example of system boundary. Actually, this is an example of a product system. This is the product system referred to cow. In fact, if we have a cow, the cow comes here in the process, we can have different results. We can have the meat and bone, the meat, we can have glycerin, biodiesel, we can have energy, we can have raw milk. I could say that we can have also leather to be used, for example, for the production of shoes. So what you basically do, once you have defined a product system that I do is to list all of the different processes, is to determine which of these processes are going to be studied in your SCA study. In one cases, you may want to determine what is the impact of the meat and meal. So you are going to cut the system in order to focus on this specific production. If you do so, you have adopted an attributional approach. So you just study what are the impacts related to a specific function. This is the case of a multi-function unit system, sorry. In the case you are not focusing on a specific function because you can do it in SCA, but you focus on the system, you are adopting a consequential approach. So you're not studying the specific meat and bone, but you're studying production of meat and bone, production of meat, production of glycerin, production of biodiesel, raw milk, and energy all at once. So system boundaries is a way to determine what processes will be included in your study. System boundaries, so once we have defined a functional unit, we go for system boundaries, can usually be classified in three different ways. There is the gate-to-gate system boundary. This only refers when only a production process is considered. Let me go back and make an example. If you study only the feed production, this is a gate-to-gate because you are going only to study this process. When is this practicable? Well, in this case, it can be practicable, it can be applied to a case like this one. This is a galvanic process. Well, in that case, there are components you have to know that don't have production, but perform on a part of the production. I'm sorry, the line dropped down. I share my screen and I kindly ask you to remind me where actually you have lost me.
Only the last few words, probably.
Okay, thank you very much. Thank you very much, Nicola. So what I was saying is basically that gate-to-gate approach in SCA, so just focus on one process, take place because we have companies that perform only one process in the life cycle. You can have a cradle-to-gate approach. So if we go back, a cradle-to-gate approach would include, for example, these processes. also including arable lands. When this process or this kind of boundaries are recommended? Usually these are recommended when you go for products like aluminum bar that you see here, that can become many other products. Let's think about aluminum. These ingots can become many different things. If a Coca-Cola company buys the ingots, are going to use these ingots to have packaging. The beverage carton company, that is part of the study, buy ingots to produce aluminum film that is used in the composition of the beverage carton. If I am BMW, I might be interested in buying aluminum for some part of my car. If I produce ski boots, for those of you who like to ski, those are used in the production of the closer of the ski boot. I will always go for a cradle to grave approach when I have a product that is delivered to the market. So if you go to a supermarket, all of the products you see there could be investigated through a cradle to grave approach. Why am I doing this? Because if I know where the product is sold and what the product is for, I can perform a full SCA. I can perform an SCA that goes also for the use stage and the end of life. In fact, once again, this is not written in the standard, but it's a good practice that I've learned in my experience. Whenever I determine system boundaries, I start by looking at this list, because this list gives you an idea of, maybe it's not super comprehensive, but generally speaking, yes, gives you an idea of what are the life cycle stages that take place along the life cycle of your product. So let's do this quick exercise together. In case of beverage carton and the HDP, we need to determine which processes are included. Well, first of all, in your opinion, which of these three approaches would you consider? Think about what I've said. Who would go for cradle to gate? Sorry, for gate to gate. So let's say I'm focusing only on one process instead of looking at the full life cycle. Okay, no one would go for gate to gate. Who would go for cradle to gate?
Me, probably.
Okay, Nicola, can you tell me why?
Because I studied the impact of the two different products from the extraction of the raw material arriving to the final product, but I don't consider the end of life.
Right. I understand this, but I was asking myself, why would you choose the end of life?
Because depend which kind of use, how to say, at the end, when we finish to drink milk, people can throw the bottles in away in different ways. So, for example, not all the bottles are recycled. Others are put in brown baskets and so on. So it's difficult to study the final process.
Thank you, Nicola. This is a very good point. In fact, if I have no data on the end of life, it would be difficult for me to go for a cradle to grave. But honestly speaking, I have to say to you that you can actually find this data, and that considering what I've said at the beginning in the objective of the study, probably the inclusion of end of life becomes fundamental if you want to compare the two packaging. But for a simple reason. The reason is that the two packaging actually has different end of life processes, very different. And if you think about a beverage carton, it's not easy, for example, to separate the three materials of which this carton is composed. So, in my opinion, I thank you very much, Nicola, to share your thoughts with us, but I have to say that I would have never excluded the end of life in this case. Even so, Nicola, thank you also because this allows me to say something to your colleagues. In the case you don't have data, specific data, a good recommendation would be to think about scenario. What are the potential scenario, in this case, of the end of life of the product? Well, in this case, it's very important because in this case, packaging has a waste problem. So we could have basically investigated what happens. A scenario could have been what happens if the packaging goes to landfill. How the impact changes if these two packaging goes for energy recovery. How this change if these two packagings are recycled instead of going to landfill and to energy recovery. But this could have been questions to be investigated as a sub-question to your big, to support the big goal of your study in order to quantify the potential impacts of the two products you are studying. In fact, I have to admit that in our case study, we have included most of the life cycle stages you've seen here. The only thing we have excluded were basically this part. We have excluded not the primary and second, sorry, not the primary distribution, but just secondary distribution. Why secondary distribution were excluded? Because the secondary distribution usually refer to the packaging and the content of the packaging. So once the packaging is filled with the beverage, in that case, what I'm doing is not moving the packaging, but moving the content. The packaging is there because I want to move the content. So the impact of transportation, in that case, should refer to the packaging rather than to the content. The point of sale was excluded. Well, these specific packaging are not meant to be stored in cool places, but in any case, more or less the impact is the same. You are refrigerating the content rather than the packaging. You are selling the content of the packaging rather than the packaging. You're not going to buy an HDPE bottle at the supermarket. You're going to buy the milk, which is contained in the HDPE bottle. For the same reason, we excluded the consumer transportation and the use. In the use stage, in the case, specific case, you are refrigerating the content. So you store the product in the fridge and you have to consume it within a few days. And that doesn't depend specifically on the packaging. It depends on the content of it. We have included transportation of waste and we have included the end of life. This is an example on how to represent the system boundaries. We have the raw material, we have the transport, we have the bottle production, the bottle filling. So between each of these steps, there is transportation. And then we have, as you can see, the end of life. Well, transport actually were included, the end of life transport of the packaging. You have also the management of the waste of the company. What you see here, once again, is not written in the standard, so you're not, you don't have to draw a system boundary diagram like this one, but it's recommended. It's very recommended in my opinion, because once you have designed this, you have drawn this, you have all of the elements to perform following part of your study, which is inventory assessment, inventory analysis. Identification of system boundaries. I recall to you what I said at the beginning of the lecture, that you go for input and output. So this box here, which was the product system, now I'm sure you easily understand what I'm talking about, because with the system boundary diagram, you see the different input and output. You see the processes. These are processes. All of these processes are part of the big box, which is the product system. This allows me to tell you also this, that you can adopt a different granularity in determining which are the processes and the boxes to be included in your study. But this is driven usually to the boundaries that you have identified, and also the ways you are going to acquire this relevant data. But go ahead, before we get into inventory analysis, there are a few other decisions that you, implementing LCA, according to ISO 14040 and 44, have to make. For example, you have to make a decision on which impact assessment methodology to adopt. It shall be in line with the goal of the study, and it should include all of the significant environmental impact. This is a principle of LCA, to be comprehensive, because in this way we avoid the burden shift. What you see here is a representation of some of the assessment categories you can investigate through an LCA. Let me make an example. If I have a CO2 emission that can result in global warming or marine water acidification. In this case, what the standard asks you is to identify which of these are to be included and explain why you made the exclusion. If your system, for example, has CO2 emission, I have to include these two categories. But in the case your system don't have any phosphate emission, well, in this case, probably I will not investigate eutrophication as water and terrestrial. So depending on the system you are studying, you are going to determine which are the impact assessment methodology and the impact assessment category to be included. This representation you see here allow me to introduce another concept of impact assessment, because these can be expressed at three different levels. The first level is called midpoint. The first level of assessment is called midpoint. This is where most of the impact assessment, life cycle impact assessment study stops. This is already an evaluation that provides you an answer to what is the potential environmental risk that I see in having these products in the market. The problem, so the same category, can be expressed also at the so-called endpoint. So if I have a risk of global warming, which is #1 evaluation, I'm just saying what is the potential impact to the global warming, so to climate change. But if you see at endpoint, you're going to ask yourself, okay, so this is the risk of climate change. But what are the consequences of climate change? There are many consequences. For example, there are consequences related to human health, because climate change is shifting the water availability. like for example in Africa, no? Climate change changing, for example, the ecosystem quality, like in our coast. The ecosystems are changing because of the climate change. Endpoint means to investigate the consequences. So you can also have a third representation. Midpoint is risk. Endpoint is consequences. Consequences can be expressed as the environmental category or as an area of protection. If you look for global warming, for example, the global warming, according to SCA methods that have been published, have an impact on human health and ecosystem quality, but nothing on resources. Resources is related to the use of resource. So whenever you have a category like biotic resource use or abiotic resource use, you will have probably the endpoint area of protection referred as resources. So what are the key takeaways of these aspects I'm going to, that I've just presented to you? First takeaway, performing SCA means to study only relevant impact assessment, not every impact assessment category. Secondly, whenever you see an impact assessment result that comes from SCA, ask yourself if those results are expressed at which level. Level 1, risk. Level 2, consequences, but expressed as impact assessment category. Or area of protection. It means consequences, but represented as human health, ecosystem quality, or resources. Let's move ahead, because there are some examples I'd like to share with you. These are examples of impact categories expressed at midpoint level. Probably the impact assessment category that nowadays is the most success is climate change. This is referred as carbon footprint. Kilograms CO2 equivalent. But as you can see, there are more than one. These are the recommended impact assessment categories by the European Union. So this is an example on how, for example, identify which categories to investigate. One can say, okay, I'm in Europe, my product is in Europe, so I'm going to follow the recommendation of the European Union that ask us to investigate these 9 impact assessment categories. Once you have identified, so let me go back a little bit to repeat. Once you have identified your goal, the function of the system, the boundaries of your study, the impact assessment category, now I've forgotten how it should be before, you can move to life cycle inventory analysis. Why now you can? Because you know which processes to study, you know how to collect this data, but because they should refer to the function. And you know which data you are interested in. Because if in your system, climate change is not relevant, is not a relevant category, in real life, climate change is always relevant. But let's say that is not, you are not going to collect emission of gases that result in climate change. Life cycle inventory analysis is the second phase of SCA that is included in 14044, and it's exactly when you collect data. Data can be on different origin. It can be primary data. These are the that you have directly measured on your system. you can have secondary data. These are usually data that you acquire from databases, from literature review, from other SEA studies. I'll make an example. If you are the company producing either the beverage carton or the HDP bottle, you will need to acquire information on the raw material production. That means, in one case, the polyethylene, HDP polyethylene production, in the other case, the polyethylene production. So the problem of plastic, you can't go to the company that sells the plastic to measure its emission. You could ask. Sometimes you get this data. In those cases, there will be primary. But in most of the cases, you will have to look at other databases. For example, you have to look into the literature review, because there are many studies published, and decide which of these databases, datasets, and or these other studies helps you to quantify the potential environmental impact of your product, because they provide you with data, input and output, referred to the process that you are studying, and the process for which you don't have primary data. In other cases, these are referred as primary, secondary, tertiary data within ISO 14040 and 44. You can go from estimation. Let me make an example. Estimation can be the result of the application of physics and chemistry. If you don't know, for example, what could be the emission of the use of polyethylene into an extruder, well, you can study how an extruder works. You can have, then you can have an energy and a mass balance of that process. But you can also refer to experts in the topic. Let me try to make an example. I can tell you from my experience, because I performed a lot of SEA studies on packaging, that the HDP bottle, the market, average 180 grams of CO2 equivalent per liter. So in the case you have information on that specific product, you can ask me as an expert, and I can give you my idea. But let's make an example. You don't have any idea of the potential impact of the energy, electric energy used for the extruder of the HDP bottle. Well, you can ask me, because I know, because of my studies, that on average, a kilowatt hour consumed in our country results, for example, each kilowatt hour is more or less 0.5 kilograms of CO2 equivalent, less than 0.5 kilograms. But this is an important data, no? Because this helps you to estimate. I can give you many, many more examples of numbers and products that an expert can give you. But don't underestimate also the help of people working company. Let's say that you are not able to assess the energy use of a specific product within your company. Well, in that case, what you can do is to collect data on the machine, like the nominal power of the machine. You can collect data on how long this is used and what is the volume of final product that is released by the machine. But then you have to ask someone, what is the use factor? So how much am I pushing to the limit of the production of the machine? Well, in this case, the expert are the workers that work directly on the machine. So this is important. This is the guideline to do what is really important. Identify input and output. What you see here was exactly the box that I have drawn at the beginning of our lecture. This box can be very, very small, like for example, a part of a machine, of a process, can be very, very wide, like, for example, the entire company or the market for a product. But no matter how big is this, or how small is this, how narrow or wide is this definition, it's very important that you ask yourself what goes in and what goes out. What goes in and out, according to 14040 and 44, you shall determine the energy and the material flow that goes in and out of the company. So let's try to make an example. If I am the company that mold the HDPE model, so HDPE bottle molding, to perform the life cycle inventory analysis of that process, molding of HDPE bottle, I will ask myself what goes in and out of the process. So let's use this representation as a checklist. Do I have energy? Yes. In the HDPE model molding process, I have energy use. What kind of energy? Electric energy. Do I have fuels? Well, sometimes I have only energy electricity. In some other case, I can have also fuels. In this case, I don't. Do I have water? Yes, I have water because that is used for the cooling of the machine. Do I have raw material? Maybe raw material, but I will have the, HDPE grains. I could go on, but let's stop just to stay within the right time. Then I can take a look at the output. What kind of outputs can I have? Well, that's for sure I have heat. That's for sure I have waste, because every process has a little waste, a scrap. 100% sure I have released water, because I have water in input, no? I have emission to air, yes. The emission to air may come from the molding of the HDPE, or also, in the case of, but this is not the case of fuel use, but if I have fuel use, it could also be emission to air related to the burning of the fuels. And I also have the final product, which is the HDPE bottle. HDPE bottle molding. This is an example on how to collect input and output data. Let's try to make an exercise. This is the process for the HDPE bottle production. So let's say that what you have seen here is not molding, sorry, I made a mistake. This was the issue of blowing. But let's take a look at this. In your opinion, what could be the potential input and output related to these processes? Let's do this exercise, but let me go through the processes so you understand. To produce an HDPE bottle, I have the HDPE grains that goes in. These are stocked into silos. The HDPE grains are then sent to an extruder, which is a machine that heats the grains in order to have the production of an intermediate product, which is called, I don't remember in English now, the plastic billet. The plastic billet is sent to the blowing machine that inflates hot air into the billet. Then you will see that the bottle will be inflated within a stamp, and you are going to have the final mold of the bottle. Then the bottle is sterilized. So we have sterilization here. This activity is performed through the use of water. And then we have other processes. Once the product is sterilized with the use of water, I will have the filling. So I will fill the packaging with the content, and I will cap it, close it. And then I have the secondary packaging that is used to make the packaging unit. So the exercise I would like to do in these last 20 minutes we have together refer to identify the input and output. You can decide for a specific process, so one of these, or you can decide to go for the big picture. I would like you to identify potential input and output, and at least according to those input and output, what could be an environmental category to be investigated. To do so, if you agree, we can make some working group. We are 20 people and participants. So what we can do is to divide into, let's say, 4 groups. And this is the question for you. You have the slide with you, look at the picture that I've just shared with you, and ask yourself, what are the input and output in terms of material and energy? What could be at least one potential environmental impact that I want to investigate? So I will create 4 sessions. I give you 10 to 20 minutes to discuss this, and I will close the session, and we're going to make 10 minutes of discussion together.
Professore, scusi, a che ora finisce la lezione quindi? Perché alcuni di noi hanno lezione tra poco.
Buongiorno Anita, io avevo inteso che finiamo a 12:15, no?
Ah, ok.
Quindi 10 minuti per voi, 10-15 minuti e poi chiudiamo in 5-10 minuti massimo.
Ok,
Quindi abbiamo iniziato almeno un quarto alle 11, 1:30, a 12:15, 12:17 massimo. Ecco.
Ok.
Per lei va bene così?
Perfetto, sì, certo.
Ottimo, la ringrazio. Quando vuole sono qui.
Grazie. E posso rientrare nella sessione 2?
Sì, scusi, devo segnarla io, non può farlo da sola? Faccia vedere un attimo.
Sì, posso rientrare.
Ottimo,
Grazie.
a tra poco, Sag. No, grazie a lei. Good morning. I have realized that some of you had some problem with this exercise. So I'm sorry, maybe I was not clear enough, but some of you were working on it actually. So I thought it was better to stay together and discuss on this exercise together. So let me share again the screen. I would like to ask to those of you who are actually discussing if you can help me with this exercise. So the question was, what can be potential input and output of this system? And what would be the consequences of this input and output in the environment? Please, if any of you would like to speak, I would be very happy to hear your voice about this.
We have things about the secondary packaging.
Okay.
But we was only in the beginning ideas. So we think about the material which is used to do that, the energy which is used, if it could be an energy from the previous process, and so we think about how to manage it.
Thank you very much, Mirko. This is the approach. You try to ask yourself what goes in and out of that process. Mirko and his colleagues were discussing and saying, okay, if they focus on secondary packaging, I'm pretty sure that there might be some material use. There will be also energy use. Then I was with Eleonora. Eleonora, can you hear me?
Yeah.
Okay, with Eleonora, we were in another example. It was the example, I don't remember if a general one or specific plastic extrusion, whatever, but basically we were focusing on energy.
Mm-hmm.
Eleonora said, yes, we need energy to perform all of these processes. And so I asked Eleonora, well, where does this energy come
From combustion of fuels that produce CO2 emission and affect the climate change.
Right. So in the case, Eleonora suggested, okay, but this energy may come from the combustion of fuels. And then I asked her, so what is the consequences of this combustion? We can have CO2 emissions to the atmosphere, and therefore we can have climate change. I can make another example. I can tell that each of these processes have a little scrap and a little waste. So there will be a waste management. How these, for example, plastic can be managed at the end of the. What are the potential end-of-life management of plastics? It depends on the plastic, but generally speaking, tell you, for example, where this plastic goes to.
Polyethylene can be reutilized in the production of water bottles.
Thank you very much, Ricardo. If you are here, sorry, if within the system, if you have scrap from here, according to the law, you can reuse it. But if you are here, so the bottle is blown and maybe filled, so after this process, this has to go to waste management outside of the company. It can be recycled, but not recycled in the same system. Or if we go to landfill, usually it's recycled.
But we can use it also like second life product.
You use a second life product after recycling, but not in the same system, because according to the national law, you are not, you cannot use waste in, for food containers.
Okay, but I cannot use it, for example, for the production of bottle, but I can use it, for example, for the secondary packaging. So for
This is good.
The bottle together.
Right, right. The question then, Mirko, would be if the company produces its own secondary packaging or buy it outside. But definitely this would be a solution. This is an approach. So you would ask yourself, if you have a waste management, for example, what are the emissions related to the recycling that might have energy use, no? Or what are the emissions related to the landfilling of that product. You may have transportation from the company to the waste management site. Well, what is the consequences of transportation? The fuel use, the fuel combustion. Oh, sorry, Ricardo, go ahead.
No, I was thinking, I was telling the greenhouse gases.
Definitely, so against climate change. But it could also be, in the case of fuels, this was also something that we have discussed with Eleonora, you can have the depletion of abiotic resources.
Okay.
So those are non-renewable sources, no? I can tell, this is the last example, and then we can say goodbye. You also have water use, no? In many of these processes. So you will have water input and wastewater output. What can be the problem related to water? In this case, in some cases, it can be a problem of water availability, which is actually an impact assessment category with the water inside. It can be a problem of pollution. So you have the pollutants into water. This is usually not the case, but maybe you can have microplastics or plastics in plastic part in the water, or you can have also altered the temperature of water. But that's the kind of impact that you have to consider. I think if you do you have any questions on what we have done today?
No, I don't think so.
Okay, so thank you very much. We'll see you next time, and we will conclude SCA and also discuss about communication on SCA results. So thank you very much. I will make sure to update the slides according to what we have seen today. I'm sorry for the missing slide. So have a good one to all of you.
Thank you.
Thank you.
Thank you very much.
Bye.
Thank you.
Bye.
Bye-bye.
Grazie Ale, bellissimo.
Grazie a te, Luca. Mi spiace per quella slide che mi è sfuggita, ma spero non sia un problema. Insomma, adesso aggiorno le slide online.
Figurati, è stato molto interessante, bravo.
Grazie mille, sai, davvero mi ha fatto
molto
piacere.
utile.
Se apprezzi mi fa molto piacere, grazie, sai.
Apprezzo molto.
Buona